Hey everybody, Mr. Gill coming to you from this awkward positioning down here because this is the only way I could fit myself in the frame. Anyway, welcome to our second full week of remote earth science. Shout out to everybody who I saw do a great job on those phenomena explanations. As of the time of this recording, I haven't got a chance to look at all of them yet, but the ones I have looked at have looked pretty good. Second shout out to everybody who was able to get the trivia question from Friday of what movie is this famous quote from? I love you, I know. That is from one of the original Star Wars movies, The Empire Strikes Back, said by Princess Leia to Han Solo. If you haven't seen that movie, what are you waiting for? It's amazing. And now is the perfect time to watch movies because literally sitting inside watching a movie is one of the best things you can do to help society out. So, what are you waiting for? Go watch the original Star Wars movies after you're done with Earth Science, of course. Anyway, so today we're going to be starting a brand new learning goal. And to do that, we're going to first take a closer look at the seasons with this little setup I got here. So, to recap, we can see that the northern hemisphere is pointed towards the sun. And since the northern hemisphere is pointed towards the sun, that means it must be summer. However, even though it's summer in the northern hemisphere, is that the same for everywhere? For example, Mexico is right here in the northern hemisphere, and so is Canada up here. Both of these places, Mexico and Canada, are both in the northern hemisphere. They're both pointed towards the sun, but is summer exactly the same in both of those places? What do you think? Let's find out. So to do that, first I'm going to turn on my sun heat lamp. There we go. So now we got that heat going. And I also have my laser thermometer that I'm going to be using to measure. So let's give it a second to make sure it's all heated up. But let's see. So first I'm going to measure the temperature of Mexico down there. And that temperature is 85.8 degrees. So that's pretty warm for summer. But now let's check out Canada up here. So Canada, the exact same time, is only 82.2 degrees. So they're both pointed towards the sun, but Mexico is hotter than Canada. Why is that? What could it be? Let's do an experiment to find out. Okay, so we just saw that even though Canada and Mexico were both in the northern hemisphere and both pointed towards the sun and both having summer at the same time, they had a different temperature. Mexico was hotter than Canada, even though they were both pointed towards the sun, both the same distance from the sun. So what could be doing that? So to figure that out, I made this little setup. So on the table, I put some graph paper down that can represent the surface of the Earth. I put a protractor here, and I taped it to a couple blocks just so it'll stand up. And I tied a string from the protractor to our sun heat lamp. And the reason I did that is so that if I move the sun, you can see it's going to tell you what that angle is. So if I have the sun up here, you can see that it's measuring at a 90-degree angle. If I put the sun down here, you can see it's measuring at a 30-degree angle. And since we know distance isn't changing the heat of Canada and Mexico, it must be something to do with the angle. So I'm going to turn the heat lamp on, give it a minute to warm up, and then we're going to see how is that angle changing temperature. But while we wait, make a prediction. What do you think is going to happen to the temperature as we change angles from low to high, keeping the distance exactly the same? What do you think? Okay, heat lamp's warmed up. Let's see what happens. So I'm going to start by looking at the 30-degree angle. So I'm going to go right here. We can see the string on the protractor that it's measuring at 30 degrees. And I'm going to measure with the thermometer what the temperature is right in the middle where the light is shining. I'm getting 81.6 degrees. You can see it saves the last reading right there. Let's move it up to a higher angle, see what happens. So now we're at 60 degrees. Same distance, higher angle though. Okay, and now I see the temperature has increased to 84.3 degrees. So just moving that angle up made it get hotter. Let's try one more. Let's move it all the way up here to 90 degrees. Again, the distance from the lamp and the ground is the same, but let's see what happens to the temperature now. And it increased again to now 86.7 degrees. So even though the distance between the sun and the ground stayed exactly the same, changing the angle changed the temperature. So, two questions. One, how did changing the angle affect the temperature? And two, why do you think changing the angle changed the temperature? Let's find out. Okay, so we just saw that when our sun was at a low angle, like 30 degrees, we got a higher temperature. And when we raised it up to a higher angle, like 90 degrees, we got a higher temperature. So higher angles have higher temperatures, lower angles have lower temperatures. But why is that? The distance isn't changing, so why is the angle changing the temperature? Let's find out. So to do that, we're going to repeat the same experiment, except this time, instead of measuring the temperature, we're going to look at how the sunlight is hitting the ground. So I'm going to give you two angles, one from that camera over there and one from my phone so we can see what's happening. All right, so first, let's turn on the sun. Got it shining bright. And now, let's take a look. So we're going to start at a low angle, 30 degrees. So when we're shining at that low angle of 30 degrees, look at how the sun is hitting the ground. Now let's move it up to 60 degrees. You should have seen the pattern change a little bit. Let's move it up one more time to 90 degrees. And we should be able to see that pattern change a little bit again. So again, as we go from a high angle down to a low angle and up again to a high angle, what is happening to the sunlight on the ground as we move from a low angle up to a high angle? Okay, and now that we've seen that pattern of how it changes, and knowing that we get low temperatures at lower angles and higher temperatures at higher angles, why do you think that changing the angle of the light is changing the temperature? Even though I couldn't see your answers in real time, I bet most of you were able to figure it out. Let's go over it in case you didn't quite get it. So, as we can see, when the sun or the lamp is at a high angle, like 90 degrees, all of that sunlight or heat lamp light or energy is concentrated in the middle. All of the energy is just shining in that small spot in the middle of the table. But when I lower the angle, you can see that the light and the heat from the light spreads out over a much wider area. So that same amount of energy is now being spread out over that wide area, so so an individual spot isn't getting as much. But again, when I move it up to a high angle, all that energy is concentrated in that one spot. So that one spot is getting more energy, so you're going to get a higher temperature, as opposed to that spot is getting less of the energy, so it's going to be a lower temperature. And so that we call angle of insolation. The angle that the sun is hitting the ground is going to affect the temperature. Here's Mr. T to explain that a little more in depth.
So the angle of insolation, key points. Insolation is incoming solar radiation. That's where we get that word, insolation. IN, solar, and then ation. Angle of insolation is the angle that sunlight is hitting the Earth. And then higher angles of insolation create more concentrated sunlight, which results in higher temperatures. We saw that in Mr. Gill's demo. Lower angles of insolation create more spread out sunlight, which results in lower temperatures.
Okay, so through that experiment, we just saw that a higher angle of insolation will lead to higher temperatures, while a lower angle of insolation will lead to lower temperatures. So let's take that newfound knowledge and see if we can use that to go back to our Mexico-Canada situation and figure out what's going on. So, what do you think the angle of insolation will be at Mexico? And what do you think the angle of insolation will be up here at Canada? Well, let's find out. So to do that, I'm going to use a protractor on the globe to measure the angle that the light would be hitting. So note that because the globe is a sphere, as I move the protractor up and down it, it's going to rotate because I want to make sure it's flat on the surface at all times. So let's start with Mexico. Got it right there. And I'm just going to take this string and make a straight line going from Mexico to the lamp. And I'm going to mark it right there. And I'm going to hold it up so you can see it. There we go. So what is the angle? Yeah, right there. It's around 80 degrees. 80 degrees in Mexico for angle of insolation. So it's a pretty high angle, which fits with our high temperatures. Now let's see with Canada. So as we move the protractor up, you can see it's going to rotate, and we'll do the same thing. Make a straight line going from Canada to the lamp. I'm going to mark the spot. I'm going to do it again. Right there. I'm going to mark the spot and then hold it up for you to see. So right there. What's our angle of insolation for Canada? Yeah, 45 degrees. Much lower. So we have a lower angle of insolation for lower temperature and a higher angle of insolation for higher temperature. Well done, everybody. All right, everybody, that wraps us up for today. So after this, make sure to go on Google Classroom, check out the assignment, and complete that. It's a little bit different today, so I'm going to explain that real quick. You'll see it's in two parts. Part one, the answer to every single question is in this video. So if you had trouble with any of that, first go back and watch the video, and if you're still confused, ask myself or Mr. T and we'll help you out. Part two is a little bit harder. That's where we're taking what we did in the video and looking at it in a little new context. So that's what's going to separate the threes from the fours. All right, so last thing, bonus trivia question. You may have noticed my amazing little bobblehead over here that represents two of my favorite characters of all time, one real, one fictional, into one amazing bobblehead. Who are these two people? All right, until next time, see ya.